Alright, every AI video you're seeing right now was generated using WAN 2.1 by Alibaba. And honestly, its results are incredibly impressive, comparable to some of the best-known AI tools available today, and it's completely free. In this tutorial, I'll take you through a detailed step-by-step guide covering the installation process, how to use text-to-image, and how to utilize image-to-image. Make sure you watch carefully to the end so you can comfortably replicate everything yourself. I won't waste your time any further. Let's get started. Here's how you can install this locally on your computer and run it for free, unlimited times. Best of all, it's released under the Apache 2 license, which means you can use it however you want, including for commercial purposes. I'll include a link to the GitHub page in the description below. Note that for now, you do need a GPU with at least 8 GB of VRAM. However, the good news is that this has already been integrated into comfyui, which is what we'll be using today. There are 4 models you can choose from, which I'll go over in just a moment. Now, let's click this link to check out the comfyui integration. This assumes you already have comfyui installed on your computer, but if you don't, I've created a full step-by-step installation tutorial for comfyui. It's actually really easy to use. So if you haven't installed comfyui yet, be sure to check out that tutorial first and then come back here. But assuming you already have comfyui installed, here are the steps to set it up. Let's go through them right now. First, we need to download the text encoder, so let's click on this link. You'll see 2 options, FP16 file, larger about 2x bigger, but retains higher quality. FP8 file, smaller and more efficient, but with slight quality trade-offs. If you have a lower-end GPU with less VRAM, the FP8 file is the better choice. That's the one I'm going to download. Now, I'll click to download it, and I'll save it inside the comfyui folder, then into the models folder, and finally into the text encoder folder. Let's go ahead and save it there. Okay, next, we need to download the VAE file. So, once again, let's click on this link and then hit download. This file should be saved inside the comfyui folder, then into the models folder, and finally into the VAE folder. Let's hit there. Now, we need to download the video models, which can be found at this link. Here's how they are categorized. The top 8 models are image to video. The bottom 6 models are text to video. For the text to video models, there are 2 main options. 14 billion parameter model produces higher quality generations and supports up to 720p resolution. 1.3 billion parameter model supports up to 480p resolution, but is much more compute efficient. If you're using a lower-end GPU with around 8 GB of VRAM, the smaller model will be the better option since it requires less computational power. Next, there are 2 image-to-video models available. Both have 14 billion parameters, but one supports up to 720p, while the other is limited to 480p. Although I have 8 GB of VRAM, I'm going to download the 720p version to test if I could generate high-quality video. I'll also choose the FP8 version, which is smaller and more efficient. Let's click download, and just like before, this file should be saved inside the comfyui folder, then inside the models folder, and finally inside the diffusion models folder. The great thing about using text to video in comfyui is that you don't have to manually create all the nodes and connections from scratch. Instead, you can simply drag and drop an existing workflow, making it incredibly easy to use. Let's start with text to video. Here's the workflow we need to download. When I click on this link, it just opens a page with code. So instead, I'm going to right-click on it and select Save Link As. This will allow me to save the JSON file wherever I want. Let's save it inside the comfyui folder. Now, let's start up comfyui. Once it's loaded, it doesn't matter what's currently on the screen. What we're going to do is simply drag and drop the JSON file that we just downloaded directly onto the workspace. And you should now see a pre-built workflow ready to use for text to video. Let's start using this right now. It's pretty simple to work with. Here is where you enter the positive prompt, which defines what you want in the video. The negative prompt is where you specify elements you want to exclude. I usually leave this at the default settings. Before running the process, there are a few things we need to check. First, let's select the correct diffusion model. Click the drop-down menu and choose the one we downloaded, which in this case is the text-to-video 14 billion FP8 model. Next, for the text encoder, Click the dropdown and select MT5-1. Finally, for the VAE model, select 2.1 VAE from the list. Now, let's set the video dimensions. Since we downloaded the 14 billion parameter model, it supports up to 1280 by 720 resolution. To see the highest resolution result, I'll change the width to 1280 and the height to 720. For video length, we need to determine the number of frames. Right now, the video runs at 16 frames per second. If we generate 33 frames, that will give us a little over 2 seconds of video. Now, of course, you could increase the video length, but you'll need a powerful GPU to handle it. For me, I'm going to leave it at 33 frames, which will generate around 2 seconds of video. Next, here are some key settings you should be familiar with if you've worked with Stable Diffusion or Flux. Each video starts with a frame of random noise, and the seed value determines this randomness. If you keep all the settings the same and use the same seed, you should theoretically get the same generation. However, this usually isn't too important, so I just set the seed to randomize. For the number of steps in general, more steps lead to higher quality video, but at a certain point, you get diminishing returns. Setting it to 100 steps would be excessive, making the process much slower. I usually leave it at the default of 30, which is a good balance between speed and quality. Lastly, CFG determines how strictly the AI follows your prompt. A higher value, like 10, makes the AI follow the prompt more literally. A lower value, like 2, allows for more creative freedom, meaning the AI might generate results that deviate more from the prompt. Then, the rest of these settings, I would just leave at the default, and that's pretty much it. So let's try this prompt. A lone warrior stands on a cliff edge, overlooking a vast battlefield at sunset. Then, let's click Q, so you can see it's loading up the text encoder. Now, it's loading up the diffusion model, and then it's plugging the prompts and the latent image into the case sampler to generate the video. Note that if you open up your command prompt window, you should see the progress of your generation. Since we set it to 30 steps here, you can see it's divided by 30. After 2.5 hours, I've generated about 50% of the video. So, it will take around 5 hours to generate 2 seconds of video at 720p quality. Generating AI videos consumes a huge amount of GPU resources, so if your system isn't powerful enough, you should consider using 480p quality instead. After 5 hours, I finally successfully generated the video using WAN 2.1. The initial result was fairly decent. Now, let's compare it with videos I generated using the same prompt in Sora, Kling AI 1.6 Pro, and Hilo AI Pro. With this result, I'll be making another video where I compare WAN 2.1 with the best text-to-video tools available today. I continued to regenerate the video, but this time I reduced the size to 600 for width and 400 for height, while keeping all other settings the same. This time, it only took about 20 minutes to generate the video. The result is pretty good, and I actually like this scene better. However, the resolution is noticeably lower, and you can clearly see the difference. By the way, this should already be saved in your output folder. So if we open up our Comfy folder, then click on Output, you should see your video over here. Perfect. That's how you get text to video up and running. Next, let's go over how to use image to video. Going back to the reference page, which I'll link in the description below, if you scroll to the image to video section, you'll see that this method requires you to have one of the image to video models installed. Again, your choice depends on whether you want to generate 480p or 720p video, whether you prefer the quantized FP8 version more efficient, or the BF16 version full quality. For me, I've downloaded the 720pf P8 version. Another required file is the ClipVision, h.safed tensor file. Let's click download, and once it's finished, we'll save it inside the models folder, then inside the clip for vision folder. Now, returning to the reference page, if you scroll down, you'll see that they've already provided a pre-built workflow for image to video. Instead of copying the code manually, let's right-click on the link and select Save Link As. We'll save this inside the 7th folder, but you can save it anywhere you prefer. Once the image to video JSON file is downloaded, we'll drag and drop it directly into the comfyui window. You'll notice that the workflow is slightly different from the text to video one. Just like before, the green node is for the positive prompt, and the red node is for the negative prompt. However, this time, you'll also see a section where you upload an image to serve as the starting frame for the video. First, let's go through each model and double-check that everything is set up correctly on my computer. I'll start by clicking on the drop-down menu and selecting the image-to-video i2v model. Next, I'll click on the drop-down for the text encoder and select MT5. For the VAE model, I'll select 1.21 VAE. Finally, I'll click on Clip Vision and choose the correct model from the list. And that's pretty much it. Now, let's start by uploading an image, which will serve as the first frame of our video. I'll select this image as the starting frame, and it will be fed into the model. Next, we need to set the width and height of the video. It's important to match this with the dimensions of the original image, which in my case is 512 by 512. For the video length, I'll leave it at 33 frames, which will generate around 2 seconds of video. Now, let's define the positive prompt. I could leave this blank, which would simply animate the existing frame, but I can also specify an action. For example, I'll input, "The woman looks directly at the camera and smiles brightly." For the negative prompt, this defines elements I want to exclude from the video. I typically leave this at the default settings. The rest of the settings are the same as the ones used for text to video, so I won't go over them again. Now, let's press Q to start generating the video. After about 40 minutes, the video was finally generated. That's when I realized I had chosen the wrong dimensions. The image was in portrait format, but I had selected a landscape size. As a result, the output only displayed the woman's chest. I swear this was completely unintentional.
Damn!
Now, let's take another look at the result after increasing the dimensions and trying different prompts. With WAN 2.1, I was able to generate text to video with results that can compete with top AI tools available today. Let me know your thoughts on the results from WAN 2.1. Leave a comment below. I'll be making more videos on WAN 2.1 soon. With WAN 2.1, I was able to generate text to video with results that can compete with top AI tools available today. Let me know your thoughts on the results from WAN 2.1. Leave a comment below. I'll be making more videos on WAN 2.1 soon, so stay tuned and I'll see you in the next video.